Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, good morning. Okay. So in this chapter, this is chapter 3, you will learn about servers, right? So in previous chapter, which is chapter 2, so you already learn in details what is workstation. So workstation is devices where end users use to done their work, to access their information and store their data, right? So now in chapter 3, you will be uh, introduced to servers. So servers is a host which actually store the data and process the data of your user, right? So right? So let's begin. So the objective of this chapter is we will determine the strategies for providing server resources, and we will also determine the server hardware features in enterprise and clusters, and we will also discuss server hardware specification when purchasing an individual server, right? So server is different from workstation, and what differentiate is actually the hardware specification, right? So you can use hardware, you can use workstation hardware such as the desktop PC to host a web server, for example, but it is not appropriate because it is not built for 24/7 operation. But for server hardware, it is built for 24/7 operation, which is needed to run a high availability application such as your web server to serve a website, right? Okay, so the outline in this chapter, we will learn about the hardware strategies, hardware features, and hardware specification, right? Okay, so let's first talk about hardware strategies, right? Okay, so first thing first, so server machine is used to provide application services, web services, database, batch computing, and so on, right? So for example, if your company is from want to host, want to provide its website, so it need to have a web server, right? So web server is actually a machine which hosts a um, web server applications such as Nginx, Apache, and if the website is dynamic, so it may have back-end scripting applications such as PHP, ASP.NET, and if in the dynamic application it need to store information, it will store it uh, on the database application. So all of this application is usually hosted on the server hardware. Right. Another example of application is, for example, email servers, and what nowadays during COVID-19 we have streaming servers and so on. Right. Even for gamers, they are running gaming servers, for example, if they want to play online games, so there must be a server which actually connect everyone, right? So they can play together, right? So a single machine might provide one service or many services. So nowadays it is a really it is very rare occurrence where only one server hardware, a physical server hardware, only serve one application. So usually one physical hardware will serve multiple application. And nowadays we have technology called virtualization. So it's virtualization and containerization. It's further segmentize the physical hardware into multiple virtual machine on top of the um, server infrastructure, right? So this means we can serve a lot of application on top of single server machine, right? So in order to reduce wastage and fully optimize all of our computing resources, right? So there are many strategies, and usually most organizations are using a mix of these strategies, right? So the common strategies are all eggs in one basket, beautiful snowflake, buy in bulk, allocate fraction. Right, so one egg in one basket, that's mean the company have one physical server, and that one physical server will serve many kind of applications such as web server, email server, DNS server, all in one single physical machine. So usually this is deployed maybe in small and medium company, right? So where they have limited resources to buy additional server capability or server space. So they put all their application in one basket. And next we have what we call as beautiful snowflakes. So we have many machine is uniquely configured. So this is probably in a big company where they have monetary resources to buy many physical servers. So maybe they want their servers to be redundant, or um, let's say they have one physical servers which they want it to only serve one particular application. For example, in banking, right? So let's say a bank. So let's say they have a big mainframe. You see, so in the big mainframe, maybe it is for their payment clearing application, right? So they have just this mainframe just doing this one task. Sorry, not one task, I mean one application, right? Maybe in a big banks, a company such as CIMB, Maybank, they have the monetary resources to do that, right? But usually in small company, they cannot afford to do this, right? And the most common one nowadays is what we call buy in bulk and allocate fraction. So this is what, like, let's say they buy physical servers and they install hypervisor on top of their physical machine. So the hypervisor is basically a virtualization software which they will segmentize, they will run multiple virtual machine, individual virtual machine on top of their physical machine. So let's say they buy a 5 physical server, so maybe they only allocate resources 10% of their computing resources, right? So that if later on there is a need to serve others application, they already have that kind of resources. So they just need to spin another virtual machine, right? So they have a spare capability. So sorry, a spare resources, a spare computing resources. So they can only do this by using a virtualization or container technologies. And we also have a server variation and alternative. So we also have a grid computing. So grid computing is what is being done in the older days. So usually they are running, for example, a Beowulf cluster. So let's say they have um, three PCs and they connect the PC together via a network. So the three PC will actually do their fair share of tasks. So let's say they want to calculate some complex mathematical equation. So they will split up the processing uh, to these three machine, right? So there is a grid. So many machine managed as a one unit. And we also have a server which we call as a blade server. So a blade server is actually a modular hardware architecture. So which actually the physical server has a one chassis, but the one chassis actually you can plug in many more servers, right? So it is a pluggable. Let's say you buy one chassis, so you only plug two CPUs. So later on, if you need more resources, you can just add in another CPUs to increase your capability. So it is what we call as a blade server, right? And also popular nowadays, we have what we call as cloud-based computing services. So this is very especially popular in small and medium enterprise and also to the big company, because why we why we need to host our own physical server infrastructure if we can rent it from, for example, Amazon AWS or Microsoft Azure, right, or the Google Cloud Platform. So we doesn't need to have a headache of running our own infrastructure. So we just renting the infrastructure from somebody else, right? And we also have what we call as software as services. So this is also famous nowadays. So for example, if the company want to host email services, so instead of building its own email services, you need to have a domain, you need a server. So instead of all the headache, why don't you just um, approach Google or use the Gmail services and buy a premium license of Gmail, right? So you doesn't have all the headache. So you just use that kind of software. So and it is hosted on the cloud-based server, right? And we also have what we call as server appliance. So server appliance is where you have a physical server which done a very specific job. So usually this is assigned to a critical application or services such as DNS, such as antivirus or sorry, security appliance, or for example, firewalls. So you have this one physical machine which actually already been pre-configured with, for example, DNS services or firewall services, right? So it's only done one thing and it will done it well, right? That is server appliance. Okay. So as we have talked about, so all egg in one basket is where one physical host is hosting various services, for example, DNS, DHCP, email services, right? But since you only have one machine in these strategies, so in order to ensure data integrity, so you need to install a RAID-based backup. So that's mean in the RAID system, your hard disk have a redundancy. You have a redundant backup. So in case one of your hard disk fail, you have another hard disk to take over, right? So this is to ensure data integrity and safety, right? And also, but there is a very high downside of this approach, since you have only one physical machine serving many applications. So in case you want to upgrade your operating system of your machine, so every time you want to do this, it will be a risky, because you need to shut down all other services just to do your OS upgrade. So it is very risky. Okay. And we also have beautiful snowflake, right? So as what we have discussed before this, so we have many machine and each machine run a specific services. So each machine is sized for desired application. For example, the RAM disk number is very specific according to the application. And the benefit is the machine will provide the best possible choice that meet the requirement. But the downside of this approach, you will have many variation of server hardware. So for example, you so for this application, for example, web server, you buy a physical server with 8 gig RAM, let's say Intel Xeon, and the brand is HP. So if you have another application, so according to its requirement, it need to run on IBM or for example Lenovo servers. So you need have another variation of your physical machine. So it will create a many variation. So you will have a maybe administrative complexity, as you need to manage many type of hardware, right? Okay, so in order so I think you can read this. So since we have many variation, in order to cater that, we need to have asset tracking. So we need to know the because server, what the vendors, what is kind of support SLA, right? So we need all of this, right? And the favorite one nowadays is we have a strategy which we buy in bulk and allocate fraction. So the one way to do this is via virtualization. So the virtualization cluster can grow by adding more physical hardware. So the physical hardware we just add it into our existing cluster. So we'll have added capacity by just adding additional physical hardware. And by using the approach, the VM can be resized, the virtual machine can be resized. So let's say initially the VM has been assigned a 2 gig RAM. So later on, let's say the application need more RAM. So for example, you have many more users using the application. You can just you can assign more to the VM. For example, from 2 gig to 8 gig RAM, so that you can increase its capacity, right? So virtualization improve computing efficiency. That's why it is a favorite nowadays, right? Of using virtualization. Okay. So the benefit of visualization is we have independence. So each VM can run on a different operating system because each VM is basically an independent machine. We have resource allocation, the RAM or memory space or hard disk space which has been assigned to one particular VM is isolated from other VM. So another VM cannot access um, the same resources of that particular VM, right? So we have granular security and we can reduce dependency health as each of the VM run its own operating system and its own library. So it doesn't depend on application from other VM, right? Okay, so since we can run many VM on top one physical machine, so that means we must have a good VM management as you need a good inventory, so you can know, okay, so this VM, who is the owner, what kind of application running on the VM, when should we shut down, or maybe when the last we upgrade the operating system of the VM. So we need to keep track in all of that in order to have a good VM management. Okay. So in this strategy also, the one of the advantages of virtual machine, right? So actually we can do live migration of the VM. So for example, you have two physical machine, right? So for example, one physical machine running, for example, 10 VM on top of it. So if let's say the physical machine is, we want to do some maintenance on that particular physical machine, we can easily just migrate that particular VM into another physical machine without impacting any services, right? So that is one of the uh, advantages of live migration. Okay, so this is for examples. So let's say we have physical host A and B. So let's say we want to do maintenance on server A, on the physical server A. So we can easily just migrate the VM from server A to server B. Or maybe let's say the server A has too much, we have used too much of its resources. We want to load balance the computing resources among different servers. We can also use live migration for that purposes. All right. So I think this is you can read on your own. So we need to do VM packing and spare capacity for maintenance. So this is for effective management of computing resources on your virtualization platform. Okay. Right? So we also have what we now have a better technique, in my opinion, a better technique than virtualization. So actually, we use containerization. So actually, by using the container, we can separate the application at the kernel levels, right? For example, so example of container software, we can use Dockers, Mesos, or the most popular container clustering software nowadays is a Kubernetes. Okay. So we can see if in the physical machine, all right. So for example, the lower one is the physical infrastructure. So in the physical machine, the virtual machine will run on top of the hypervisor. So each of the virtual machine has its own guest OS, right? It means different operating system. For example, this is Ubuntu, Fedora, and different one. So instead of we install operating system for each of the VM, why don't we just separate, or we partition the application, for example, in same OS, right? So basically in the Docker engine, right? So each application has its own library, its own bin, its own separate memory space. So this is a Docker. So Docker have a better efficiency and better performance than virtual machine. Okay, right. So this is what we have discussed before, the grid computing, which we have multiple PCs and we connect it together via a same network. Then all the machine will run as a single unit, maybe let's say to solve a mathematical equation, or maybe do some DNA sequencing or something. So we can separate the complex tasks into many we can separate the task into two different physical machines. So that is a grid computing, right? Right. So you can read this on your own. Right. And we also have what we call as blade servers. So So if you can see, so this is example of a blade server. So one chassis, you can cram in maybe one, two, three, maybe for example 20 machine. So let's say you want to add in more resources, so you just slot in another blade server into the main chassis, so you can have additional resources to that particular chassis, right? Okay. And this is the cloud-based compute service. So nowadays we can rent our virtual machine, so we doesn't need to host our own. We can just rent computing resources from Amazon AWS, Microsoft Azure, and Google Compute Engine. Okay. So what is a cloud? So different people have different opinion about cloud. So for consumers, so they will thought that cloud is when they put data on a web-based platform. For business people, they will kind think of cloud is something that will save them money, right? Because they are business people, so they will think that cloud is kind of renting a computing infrastructure, and it should be elastic. So the way we've been built, how the hosting company or the cloud company build the company, it's elastic. It is only pay per use, right? And for IT professionals, okay, so according to them, that cloud computing is maintaining hardware and network, so the customer can focus on higher level of abstraction such as OS applications, so they doesn't need to um, think about the physical infrastructure. So they are more focused on the higher level of layers of such as application and operating system, right? So cloud computing come in with the cost benefit, because um, computing hardware become cheaper, but the operation of computer has become increasing expensive. So by the increase of operating cost diminish and often eliminate the cost of reduction. So if we centralize, so we ask the big cloud provider to handle all of it, so it can benefit from economy of scale, right? Okay, so also very famous software service, as I mentioned before, example of such services such as Dropbox, Google. So for example, if you want to have a large cloud storage, so we can just subscribe to Dropbox. So we doesn't need to bother about how we want to border on how we want to store our data. Maybe we need to buy a server space. No need, right? Because Dropbox will handle all of it. The one that we only need to concern is our internet connectivity, right? So if we have our data, so we just upload it to Dropbox, and Dropbox will take care of the rest, right? So this is a software as service. Right? So this is an appliance. It's a device designed specifically for a particular task. So you can see that we have file server appliance, web server appliance, email appliance. So this is the physical server. So for example, it is running a very specific services, and usually we expect this appliance to do its job well, right? Because it is a dedicated appliance, and it's also usually very expensive, right? Because it's also include a proprietary software on top of the hardware, right? Okay, so usually most of company doesn't just use one strategies. They also actually employ a hybrid strategies where maybe for small organization they have few snowflake and possibly a few eggs in one basket. In medium organization they are start using virtualization, and right, so for large organization they have a little of everything. So they have small, they have snowflakes, so they have X in one basket, and they also have a bulk and orchestration, which they use virtualization. Okay, all right. Okay, so server hardware features, right? So we go into the server hardware. So what uh, in here we will discuss what is the difference between server hardware and workstation hardware, right? So server hardware generally falls into two major categories. So we have enterprise categories and clusters. Okay. So this is example of servers being deployed in a data centers. Okay. So usually the servers is uniform machine, and it is high. It doesn't have a monitor or something. So it is being built to have a high efficiency and low in order for us not to waste any resources. Because if we fully utilize resources and we reduce our energy consumption, we can save a lot of money. Okay. Okay, so in term, so the hardware design differences. So for server, of course, it will have more CPU performance because it need to run multiple application, and we need the servers need also to have high performance I/O. So thin, because the servers usually receive data and store data. So it's usually it will often use its input and output interface. So it need to have high performance I/O. Maybe the network interface need to support 10G interface, and its PCIe bus need to have a very high bandwidth of interface, right? And the server hardware should be expandable. So let's say we need to add more RAM, so we can we the server need to have a extra slot, so we can add in more RAM, more hard disk, right? Okay, and it is need to be upgradable. So the most important, it is must be rack mountable, because in data centers usually server is mounted in a rack. So usually when with it is rack mountable, it have a size. Usually we have 1U, 2U, or 3U. Okay, it must have a high availability option. So as I mentioned before, in physical server, we need to the server need to have a dual power supply, and it have the hard disk must be in a RAID configuration, so that the hard disk have a backup in case the main hard disk fails. Okay, and we must also have a remote management capability where we can remotely access our servers without we are physically in the data center, so we can access our server from anywhere and securely, right? Okay. So even for the OS is different. So usually Microsoft any operating system have a server version, because it is been built for efficiency. For example, in Windows, so we have Windows Server Edition. For Linux, we have server, because in server version it doesn't have a GUI, or it have very minimal graphical user interface, because the system we are more focused on reliability and secure. So the code base must be smaller, and the security must be top notch, and the OS must be patched with up to date security patches, right? And the network configuration, usually we doesn't use DHCP. Each server we will use static, right? So we use hard coded configuration. All right. Okay, so for server availability, so we have a different level of redundancy. So the server should at minimum have n+1 redundancy. That means it have enough spare capacity for one failure. So for example, we have two power supply. If one power supply fail, it have another power supply to take over and alert the administrator, so that system admin can replace it when available, right? And maybe for a super critical server, so we need to have n+2 redundancy. So that's mean it have enough capacity for two fail event. So for example, it have three power supply. So even if of the power supply is down, it has still one more, right, to make it continue running. Okay. Okay. So for data integrity, as I said before, the hard disk must have a RAID, must be set up in a RAID configuration. So in RAID 1, it stores all data twice, so once on each disk. So it has two disks. So each of the disks mirror each other. So if one disk fail, another will take over. We also have a RAID level 2, which is have higher redundancy. It have more hard disk, right? So in case of two failure, so it can have maybe another two to support the data storage. Okay. So in order, we can also provide data integrity by using a non-RAID approach. So maybe we can use for example, distributed file systems such as Google GFS, Hadoop, which the data uh, is being split into multiple units, right? So each of the multiple units is being stored into different physical machine. So for example, if one physical machine is down, the same data is available at another machine, right? So not all information is lost in case of when one physical machine is down, right? There is an example of GFS or Hadoop. Okay, so the server must also have a hot swappable capability. So for example, if the power supply is down, so we can replace the faulty power supply by not turning off the whole system. So we can just swap it. So let's say we just remove the faulty power supply and just install the new power supply. And this should be also applied to hard disk, right? So we doesn't need to power down all the physical servers, so we can just replace the faulty hard disk while the system is live. Okay. Okay. So the most important thing, server should be stored in a computer room in the data center where the environment is being controlled. Don't put your server under your work desk or maybe under your cardboard or something, because server should have a good reliability. So in order to ensure good reliability and security, we need to install it in a computer room or in the data center. Where in the computer room, the temperature is being regulated around 10 to 35 degrees Celsius, and it's rack mounted, and it have a fire protection, and it has good networking, and also in case there is something happen, right? So maybe someone try to break in into your data centers, it have a physical security, for example, a CCTV or lock to prevent any physical break in into your computer's system, right? Okay, so we must also have the capability to remotely managing our servers, right? So I said before, it is very tedious if we want to do any changes. We need to go into data center physically. So it is not very efficient. So usually people will install a remote access software on your servers. So usually we will use a remote access protocol such as Telnet and SSH. But Telnet nowadays not many people use it because it is not secure. When you use telnet, all the communication between your laptop and your server is not encrypted, so we need to use SSH because all the traffic is encrypted. Okay. Okay, so we also can use out of band management. For example, if let's say your data center is totally isolated, maybe due to a network failures, you still have a out of band management, so you can access it via a non-traditional network. So maybe you can use a secondary network so that you can remotely access your servers in case of network outage, right? Okay. So this is example of out of band management. We can use KVM switch, okay, console switch. Okay, right. So for server hardware, usually we should have a vendor SLA. So because, for example, we are buying the servers from HP, Hewlett Packard. So usually we must sign an SLA with our vendors. So for example, uh, uh, in the SLA, so let's say we have one hard disk failure. So if we open up a ticket or we report it to our vendors, the vendors should able to replace our faulty hardware within 24 hours or maybe 4 hours, depending on SLA agreement. So SLA support agreement is very expensive, so we must balance out, right? So maybe we can it is enough to have 24 hours response time or next day option, right? To save a cost. We should also have a spare part. So this is, for example, RAM, or for example, what more, hard disk. So we must have a spare. So let's say there is a faulty part. So maybe we doesn't need to wait for our vendors to replace our parts. So we can have our own spare part, which we can replace the faulty parts in our own. So we must have a warehouse or maybe a cabinet which we can store all of the server spare part. Okay. All right. We also must track the service contract. Okay. Because we have different machine, and this different machine may be being added into inventory later on. So of course all of these server will have different support period. So for example, the newer machine maybe have 2 years contract, but for the oldest one maybe the contract only left for 6 months. So of course we need to keep track on the service contract, so that we know which one will run out and maybe we need to renew the maintenance contract. Okay, so the bottom line is we must have the mechanism to track all of these service contract. Okay. Okay, so for the hardware specification, server performance is very complex, but in general, an application is usually waiting for one of four things. So let's say the application is loading, maybe because it is waiting for a disk or CPUs, memory or network. So the bottleneck is usually at these four elements. Okay. Okay. And usually in server we have different model and product line. So of course, for example, a Dell, they have a power edge model and product line, and maybe they have a product line which is very suitable for rack mounted, and maybe they have a product line which is for blade, or maybe they have product line maybe for high performance or lower power consumption. So they have different model and product line for different purposes. So we need to know what these different models or product lines offers, right? So we cannot simply just buy a server. So we need to do our research on what these particular models or product line provide us with, the features and capability of certain models and product line, right? Okay, so in server hardware, all right, so the CPUs, right? So usually the server run on CPU grade, in server grade CPUs. For example, in Intel, usually it's run on Xeon server line, and for AMD it run on Opteron server models. Okay, so so the usually in server CPUs, it's usually a multi-core CPUs, and the multi-core CPUs we have many caches, so it will support L1 caches, L2 caches, and also L3 caches, right? So this is example of different CPUs for server line for Intel Xeon. So for example, the highest one, the most expensive, maybe it have 18 CPU cores, and the CPU frequency and different, when we times the CPUs and cores, we have the aggregated speed, right? So, but I think this is the outdated one. So I think the latest one, maybe we have a newer version of Xeon range. Okay, and in order for our application to fully use multi-core CPUs, our application must support multi-threaded and multi-core CPUs, right? So the way the programmer program the code of the application, it must be multi-threaded and support multi-core CPUs, or not. If not, you have these many threaded and many, maybe your CPU have multi-threaded capabilities and maybe have many cores, but your application cannot support it, so it cannot fully utilize all the multi-cores and multi-threaded CPUs, right? Okay, right. So the memory also, nowadays we have a new, it must have support a NUMA, so it can increase its memory latency. So for example, we have a very low latency, so we have a more memory which is very fast, and this is important. So your server hardware, I mean your server CPUs must have a cache, right? So that we can improve performance, right? So if let's say the L1 cache is where the cache is being stored on the CPU core itself, or we have L2 cache which near the core, or we have L3 cache which we can share among all other CPUs, and we can also have L4 cache. So the bottom line is modern processors should have multiple level of caches so that the application when it want to sorry, for example, for CPU, if it want to process a data, so for example, it doesn't need to get the data all the way into the hard disk or the SSD. So it can, let's say, want to process the same data, so it can just fetch it first time from the SSD, then cache it on the cache. So the CPU, instead of all the way accessing the data on the SSD, so we can just access it from the cache. So it will increase performance and reduce latency. Okay. Okay, swap phase. So swap space is also features of OS. For examples, if maybe the server have limited memory, right? So for example, if the server only support 4 gig of memory, only have 4 gig of memory, but it have a lot of disk space. So for example, so maybe the application need additional 2 gig of data of RAM. So in operating system, usually we can use swap space. So actually it can use a virtual memory. Actually it can map some of the memory needed for the application into hard disk, not into the RAM, right? But the downside is if we store our virtual memory on a disk, on a hard disk, it will be 100 times slower compared when we store it in the RAM, because RAM is very fast, hard disk is very slow. Okay. Right? So the network interface, okay. So the network interface in the server hardware, usually it will have multiple network interface. So not like our workstation which maybe we have only one interface. So for server, usually it will have minimum of 2 network interface, and for example, one port have 10 gigabit per second. So in order to provide redundancy, or maybe we want to increase the bandwidth, we can gang it together. I mean, we can actually combine both of the physical interface into one logical interface by using what we call as bonding, right? So actually the server will have, when 10 gig plus 10 gig, so we have to add 20 gig of one interface instead of two interface. But actually the physically we have two interface, but we bond it together into one interface with bigger bandwidth. Okay. And also if we have a bonding, for example, if one physical interface is down, maybe the cable is being cut or something, it still have another physical path, right? So it also for redundancy. Here's an example. So the switch, all right. So we do link aggregation or teaming. So the server we have will gang up, will bond the two interface into together, and combine the bandwidth of both interface. Okay. Okay, now RAID. So we have talked about RAID before this, redundant array of independent disks, in order for us to have a redundant hard disk. So RAID, we can implement it via a software, which we call as software RAID. So the software RAID is actually just only a driver in our OS. So actually we have, let's say for example, if you want to set up a RAID 1 hard disk, so we install two hard disks into our servers. So in our operating system, for example, Linux, or for example in Fedora or Ubuntu. So we use the RAID driver, the OS part, in order to handle the RAID configuration. So for example, if we store one data, it will automatically mirror it into another hard disk. So the one that handle it is OS. So it's all been done in software, but it have some downside. If you use a software RAID, it is not very high performance. The performance may be low because we do it in the software levels, and maybe if the software have some issues, so the rate will also be compromised. So that's why people introduce hardware rate, which we have a dedicated hardware which we slot in into the server. So actually the rate card which will dedicatedly handles all the rate configuration. So it will the one that will automatically copy the data from one hard disk to another. So we doesn't rely on operating system or the software. We rely on the hardware rate. So this provide a better performance, but the downside is it is very expensive because we need to buy additional card and we need to slot in into our PCIe interface. Okay. The power supply, just I said before this, we need to have a redundant. So for server, the minimum one we must have n plus 2. So n plus 1, for example. So that means we have two power supply. If one fail, so we can have another one running, and we must kena cepat-cepat lah, alright. We need kalau satu dah rosak, kena cepat-cepat tukar, right? Okay, and also we need to have a UPS, uninterrupted power supply. Okay, and generally in data centers, both of the power supply is being connected to different power distribution unit. I mean the PDU box. For example, if the one PDU box lost its power source, we have another PDU box which can supply the power to our server. So this is for redundancy. Okay, and also in server, right? The things that we because server, it doesn't need to be beautiful or doesn't need to have unnecessary thing, because server we only interact with it remotely, right? So that's why we doesn't need a video card, keyboard, monitor, doesn't need, because server is something is in a data center, and people see it in the form of website, in the form of email. So we doesn't interact it with directly, right? So that's why it doesn't need to have fancy video card, keyboard, monitor, because if you are adding all these extra things and you doesn't use it, it's just waste of energy, waste of resources, and maybe for cooling, so it will um, increase the heat and you need more electricity. So in order to make things efficient, so for example the server, so we only keep the essential part, right? So if you can see in the Google data center, so this is example of one of the Google servers in one of many of their data center clusters. So the server hardware is being kept in the minimum. So it will has only a CPU, a RAM, and hard disk, right? And the motherboard and network interface. It doesn't need to have all the fancy casing or RGB light or nothing, right? So please keep server hardware to ensure the efficiency, right? All right, so we have come into end of chapter. So in the chapter, yes, you have a lot thing of digest. So I highly suggest that you do do your own reading with your book. If you have any question, you can ask me, right? So I will see you guys on chapter 4 next week, right? Assalamualaikum warahmatullahi wabarakatuh.